down. Let's get the rules down.
Halfway through the lecture.
Rules. Let's get the rules down. Let's get the rules down.
What's the date?
And 314.
Today is 10/5/10.
Were we 328? Thank you. 314. That's just 314/28. Okay, for 314/28. And we see 314.28. 314.28, mainly A. Mainly A, our concern. Mainly A. Okay? 314.28, mainly A. Let's review it. Rule number 1, straight. Straight pull. Straight pull, the rule for straight pull. What do you do? Anybody? Bread. Pick on bread. 8 times largest conduit plus anything. Do you add anything? Nothing. What's the size of the conduit? The trade size of the conduit in inches, not in square millimeters or millimeters. Okay, so that's a straight pull. Anything else for a straight pull? 8 times the largest. Why 8? Because in the code they say 8. It could have been 7 had they made up their mind and they said 7. Angle pull. Angle pull. Maybe I should this way. Angle pull. What's the rule for an angle pull? 6 times the largest conduit. 6 times largest conduit plus all others on the same wall. In the same wall or on the same wall. Are we on the same page here? Why 6? Just because the code says 6. Could it be 5 if they modify the code in 2014? It could be. Any question, guys? Mr. Irbab, see where the 6 came from? I think the mistake yesterday, I used the conduit 6 and the 6 and it confused you guys. Today I was smart enough not to use any conduit that's 6. Okay, so 6 times the largest plus all other conduits. Questions? Questions? The last poll. The last poll is called U poll. U as in DJ. U poll. For the U poll, my friend, the code says NEC 314.28a. What does it say? 6 times largest conduit plus all others as in conduit on the same wall. Questions? These are the rules. 3 simple rules. 3 simple rules. 3 simple rules. Any question guys about the rules? Any question about the rules before we start doing anything? So that took us 3 minutes just to go over the rules. Any question, guys? Am I going too fast, too slow? Right speed? Okay, we'll take that one. Go back again. One more. Any question about this, guys? All right. There is one special rule. Probably should spell special right first. One special rule. Conduits housing same conductors. Distance between them equal 6 times largest conduits that house the same conductors, the distance between them, edge to edge, must be 6 times the largest of each one of them, plus nothing. That's only if they're housing the same conductors. Only if they're housing the same conductors. Here's a conductor coming from here to here. The distance right here between them, D, is the distance that we're talking about, edge to edge for conductors. Here's conductors housing the same. Conduits housing the same conductors coming from here to here. The distance between them is D. This is the distance that we're talking about. Any question, guys, about the second rule or one special rule? What I call it, one special rule. Only if they're housing the same conductors. If they're not housing the same conductors, who cares? Any question? Based on these two rules, we're going to go over this example. Okay? Questions, my friends? Now, do we know, Mr. Erbab, do we know why 6 and 8? Mr. Boo, do we know why 6 and 8, my friend? Why do we multiply by 6 and 8? Why do we add all others in one time and we don't add it for the straight, but we add it for the angle? Because the code says so. Everybody knows why do we have these rules, guys? Why are we doing these rules? Because of bending conduits. If you don't adhere to these rules, you will damage the insulation of the conductors as you pull them either straight or with an angle, especially with an angle. You have to have enough room, first, to work as you pull these conductors, second, to bend them without damaging the insulation. Okay, questions? As long as we're on it, guys, let me just add one more rule. I want to call this one special rule number 2. Special rule number 2. If you have a conduit coming from the back of a box, opposite to it is an open door, you apply this rule. Only if you're coming from where? From, I'm going to draw that one because it's easier drawn. I have a conduit coming from here, right in the back, and right in front of it is an open door. You apply this special conduit. To do that, guys, you need the conductor size. Let's assume it was always 500 kcm. This rule will give you the depth of the box. This rule applies to give you the depth of a box if you have a conduit coming from the back, opposite to it is an open door. That's the rule. To find the depth of the box, you're going to take the conductor size, you're going to take this one to table 312.6a under one terminal. There's multiple columns there under one terminal, not two terminals. And so special here is you're going to go one, they call them terminals, right? Yes. Yeah. Terminal. Under one terminal. Let me erase it and write it right here. Under one. And based on this, guys, this 500 kcm, based on table 312.6a, if I have a 500 kcm, one conductor or 15 conductors, doesn't matter how many of them. Based on this, the depth of this box should be, Brad, thank you, 6 inches. So the depth of this box should be 6 inches based on this example. Special rule only if the conduits are coming from a wall and opposite to that wall is an open door. It can be back to front, side to side, top to bottom, as long as there's a door that can open opposite to where the conduit is entering.
How did you know it was 6 inches?
How do I know the 6 inches? Good question. You go 312.16 table.
6 or 16?
It's 6.
312.6. Thank you. 312.6a. Are you guys there? 312.6a. Under one terminal, Not here. Not here. Not for this rule. You use it for other rules in the code. This table is used for other rules. If you're paralleling, for example, multiple conductors in other rules, they take you two terminals, mean you're bringing two conductors, and one goes in one log, the other goes in the other log. For this rule, you always apply the one terminal. But that table 312.6a is used for other applications in the code.
You do that.
No, one terminal, regardless of how many conductors you have. Good point. Regardless of how many conductors coming out of this terminal, out of this conduit, I could have, for all practical reasons, should. There's conductor 1, with phase A, phase B, and phase C, okay, and a neutral, just to make DJ happy. Here's a circuit. All of them are 500 kcl. One terminal.
It's like because it's one terminal station.
It has nothing to do with the terminal. It just has to do with the depth.
Oh,
Yeah.
okay.
Yeah, that's in the journeyman exam. They will tell you we're paralleling conductors coming from the back. So thinking if we're paralleling now, we need two terminals. So it confuse you to go to the two terminals. We would go to two terminals under other applications in the code, guys. For this particular application, regardless of how many parallel you are coming in this conduit, you go by the largest conductor in any conduit coming from the back. So if I have two conduits here, one conduit has 3 conductors, 500 kcm. The other conduit has 3 conductors, 750. I go by 750 and size it, regardless. That's the only place where you can get the depth of the box from any C code book. Questions? Mr. Rabab? Questions? Okay. Camille? Mohammed, my friend? Good? This is going to be new too, just for the record. Okay. Nobody is in a smiley mood. All right. I'm going to draw this, and we're going to put right, left, top, bottom on it, and we're going to do what we did, guys, yesterday, without getting confused between right, left. Here's what I'm going to do. I'm going to use color coded from the get-go. So I'm going to use black. Black is for the box. Anything I want to draw in black is going to be for my beautiful box that you guys are watching here. Chad, draw this box. And I'm going to come right here with conduit 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4. And here's my 5th conduit. And there's 5 conduits in every side. 5 conduits in every side. That's one for the record, huh? 5 conduits in every side. 2, 3, 4, 5. DJ, can you count in Spanish? 1, 2, 3, 4, 5. Okay. 5 conduits from every side. That's as ugly as it gets. Let's establish directions and dimensions and all this good stuff. So 5. Let's put the dimensions of each one of them. This is a 2.5 incher. This is a 1.5 incher, a 1.5 incher, and a 3.5 incher, and a 3 incher. And here's a 3 inch, a 4 inch, another 4 inch, and a 2 inch, and a 1 inch. And on this side is 2.5 inch, and 3.5 inch, and another 3.5 inch, and another 2, and a 3er. And way at the bottom, I have 3 inch here, and I have 5 inch here, and another 5 inch, that big boy. And I have a 3.5 inch, and the last one is 1 inch. Here's the conduit. 5 conduits from every side of this gearbox, or pull box, sorry. Now, if I give you this one, Ryan, and I say, do the calculation for it, you have no idea how to do the calculation because I have to establish the route of the conductors. How am I going to route my conductors in it? So I want to go route my conductors in colors.
I have a question.
Yes, sir.
Is that on the bottom, second from the bottom on the left, two or three?
This is a 2. This is a 2. It's written in Arabic. Any question, guys, about the given? Okay, color code them. I want to color code them. I'm going to use blue. Straight pole is blue. I want to use red for what do we have? Angle pole, and I want to use a green. I want to use a green for U pole. U pole. Okay. I will use. See the color code? I'm going to be using straight as blue, angle is red, and U is green. So wherever you see the green, it's going to be a U pole. All right, let's do the green. U pole. Based on what Chad is saying, I need a U pole right in here. Can you guys see that? Came and went in here. Here's my U pole. Went all the way out. And I have a U pole that's coming out of these two. Okay? And I have a U pole coming out of these 2 4-inchers. And I have another U pole coming out of these 3.5 inches.
Is that one 2 point? Is the fourth one from the left on the top?
This one?
I can't really read it.
2.5, 3.5, 3.5, 2, 3.
On the top.
Oh, sorry, on the top. 2.5, 1.5, 1.5, 3.5. This is 3.5. Yeah, it sounds like 3, but let's use that. 3.5. 3.5. Okay. Any question, guys, about the U poles? Everybody knows where the U poles are? My U poles are green. I want to go ahead and use my angle poles are going to be red. My angle poles are going to be red. So I'm coming with angle poles. Angle poles. Here's one angle pole. Here's another angle pole. A third angle pole. And guess what? A fourth angle pole. Did we miss any? I have 4 angle poles, 4 U poles. What's the last one left, guys? Straight poles. How many straight poles you can have in a box? How many straight poles you can have in a box? You can have as many as you can, but right, left, left, right, left, and top, bottom, you can only have 2, right? One top, bottom, and the other one is right, left. So, as you guys expect, this will be, what color did you? Blue. My Mr. Blue is coming out of here. I'm going as a straight pole, okay? And I have another one, which happened to be 2. This is coming, okay. I have 2 straight poles, 4 U and 4 angle.
I think
Poles.
3s or 2s. 1.5, the blue one there.
The blue, this one?
Yeah.
3.5.
Oh,
3.5.
You sure?
The straight poles are 3.5. Yep. I'm sorry. The straight pole is 3.5, 3.5. Anybody else have any comments? Okay, let's establish the directions that we're going to be going through. I want to call this one, where's my top? The top of this. How am I going to put my top? My top is, we use a different color.
green.
I don't want to miss it. So I'm going to use his, this is, let's use red for here. Okay, first of all, this is my right side. So this is my right side. Where's my left then? This is my left. This is my left. Where's the bottom?
On the top.
The bottom is here. And where's the top? Top. Oops. Top. Okay? Top. Top. Okay, let me repeat this one. This is a top, left, right, bottom, because that's the directions that we're going to be using. Any questions guys about this box before we go ahead and start? Any questions? Yes, sir.
Do boxes usually come this full? I mean,
You could. Oh yeah. This is America, man. Big stuff, big things, man. Right? Except Ben, he should live in Europe, man. He rides his bicycle all the time.
Yeah.
It's what Europeans do. Better than riding your horse. Any question, guys? Any question? Should I move to the next page? Should I move to the next page? Eric, my friend?
Yeah.
Good? Muhammad, Mr. Irbab? Brooks, you're so quiet. You scare me when you're so quiet. There you go. Good? All right. Now I want you guys to keep an eye on the dimension as we go through the calculation. So what do we need to do? We need to go find, I'm going to use a black. I need to go find the dimension of this box. Here's the first dimension of this box. I'm going to call this dimension X. And I'm going to find the second dimension of this box, or the height of this box. I'm going to call it, expect what? A Y. I need to find the XY of this box, the dimension of this box, the width and the height of this box. The width and the height of this box. Okay? The first thing that you should ask yourself is, guys, first know how many, the different type of poles that you have. Number two is, you have to concentrate on finding one dimension at a time. So, since I like to start always with the x-axis, we're going to start with the x, find the x, and then we're going to move and find the y. And then after that, you go have a break. How about that? Any question, guys, about the x, y of this box? We're cool? Everybody is there? Okay. Should I move to the next page?
Yes, sir.
Or should I stay here forever?
And count chickens.
Don't talk about my chickens. You're on record, man. Mr. Boo, good?
Yeah.
All right. Let's go ahead and start. So the first thing you're going to ask yourself, guys, what color did we... okay, let's do the color. First of all, I'm going to do the X. So, finding X dimension. Well, just X. You guys will write the dimension. X. Oops. There you go. Finding X. What color did we use with a straight pole? Just remind me. Blue. So I'm going to be using a blue. I'm going to use a straight pole. Why the straight pole first? Really, there's nothing. Just we put them. Did we say we put them in an order with blue? And what's the other one? Was it U and angle? Let's do a straight pole. Straight. Straight pole. Straight pole. Now remember, guys, we're looking at X. We're looking at X. If you go back for straight pole X, looking at X straight pole, which one goes? We're gonna go left, right? To get X, you can get X left to right or right to left in a straight pole. Can you get it from any other way? Either left to right or right to left. Can you get X from top to bottom? That's a Y. Okay, so I'm gonna go left to right. X, left, straight pole. Number one is left to right. Left to right. What's the rule? 8 times the largest conduit involved. The largest conduit involved in this pole. What was the largest conduit? Left to right. 2. So 2 equal 2 inches equal 16 inches, right? Then I'm going to go right to left. The same thing, 8 times the largest conduit, right to left, the same conduit, 2 inches equal 8 times 2 is 16 inches. Any other straight conduits, guys, going right to left or left to right? Any other straight conduits going right to left or left to right? From to get this a straight pole. Any other conduits? No. Okay, let me see what color did we use there. I'll go back just quick here. So we're going to use the angle pole with red. We're going to use red with angle pole. Any question guys about the straight pole? Straight pole, straightforward. Just one. As you can see, guys, both of them are the same if you're doing the same conduit. Okay, let's go ahead and do the angle. Angle pole. Angle pole. We're still talking about X. Angle pole, we're still talking about X. So let's go back and see, to get X, angle pole, how many angle poles can I get X from? I have going from left, I can go from left to bottom, or from left to top, or from right to bottom, right to top, right? Can you guys see that? Left to bottom, left to top, right to bottom, to top, right to bottom, for calculation. Everybody can see that? Everybody can see that? Okay, since we all can see that, and I'm gonna go, guys, right directly and just go to a different page. We're doing it. I'm just going to a different page. We're still finding X. We're still doing the calculation for X, and I still use red, and I'm finding angle pole. I'm finding an angle pole. Okay, let's start from left to top. Left to top. Okay, left to top, guys. Coming from the left, going to the top. What does the code say? 6 times the largest conduit entering the left, plus all the conduit on the same side of that conduit, which is the left 2. So can you guys see? So I believe 6 times the conduit entering the left and engaged to go left to top is 6 times 2.5, right? 2.5 plus all the other conduits on the same wall. All the other conduits in the same wall. So a 3.5, that will give me a 3.5. I need a calculator. And 3.5 plus 2 plus 3. I need 2 gentlemen, or a gentleman and a lady, to agree on the answer. So 6 times the largest conduit entering from the left, engaged in the U-pole. It has to be engaged in the U-pole. The largest conduit engaged in the U-pole. How much? 27. Anybody else? 27? Okay. 2 gentlemen would never disagree on something right. Or a gentleman and a lady too. 27 inches. So left to top give us 27 inches. Okay. How about if since we're the left, Brad, let's go left to bottom this time, and then we'll move to the right. Okay, left to bottom. Okay, so we're at the left. We're going to do left to bottom. 6 times the largest conduit, doing a U-pole going from left to bottom. Which one conduit? Largest conduit engaged in the U-pole that's going left to bottom. Which one? 3 inches. Plus all the other conduits in the same wall. 2 plus 3.5 plus, I'm going 3.5 plus, so I have 3, 2, 3.5, 3.5, 2.5, 2.5. I need a gentleman to give me the answer. How much? 29.5. Another gentleman. 29.5. 29.5 inches. Two gentlemen would never disagree on something right. On my grandpa said. Any question, guys? So systematically, you start left to top, left to bottom. What do you think we're going to go next? Right to top, right to bottom. Okay? Left to top, left to bottom. We're done. By the way, how many calculations for angle pull am I going to go? 4 calculations. So I'm going to write that number here, 4. Can you guys circle, if I can, circle a 4. 4 means 4 calculations I'm going to be doing for this angle pull. I did 2. I want to do 2 more. Keep in mind, we're still calculating for what? For X. We're still calculating for X. So don't miss the point. We're still calculating for X. Mr. Urbab,
Yeah.
any questions?
You got four for the left to right, or
Yep.
left to bottom, that one only.
Yeah, we're going to go left to top, left to bottom, and we're going to move in the right now. Do the right side. Are we ready here? Can I move? Yes, no? Okay, so we're going to move. Just to remind us where we are, we're still calculating X, and we're still doing angle pull. We're still calculating X, and we're still doing angle. So now we're going to go right to top, right to top. So going from the right to the top, 6 times the largest conduit engaged in this pull, which is 6 times the largest conduit 3, plus all the other conduits in the same wall, which is a 4, plus a 4, plus a 2, plus a 1. So 4, 4, 2, 1. Any answer?
29.
29. Another gentleman or lady come up with 29?
Yep.
29. 29 inches. Okay. The second one, what do you guys expect? We went right to top. Where are we going to go now? Right to bottom. Right to bottom. Right to bottom. Okay, let's go. Right to bottom. 6 times the largest conduit engaged in this pull. So 6 times the largest conduit 1 engaged in a pull. Plus all the other conduits in the same wall. 2 plus a 4 plus a 4 plus a 3. Okay? What's the answer? 2 gentlemen or a gentleman and lady? 19? 19, 19? Okay, good. 19. 19 inches. 19 inches. So I have 2 calculations for a straight pull, 4 calculations for an angle pull, and I'm going to have 2 calculations for the U pull for a total of 4 plus 2, 6 plus 2, 8. 8 calculation. And Brooks, my friend, you're going to choose the largest number that you can come out of these 4 calculations, the largest dimension. Does that make sense? 8 calculations total. 2 for the straight, 4 for the angle, already did them, and we're going to be doing U-pull. If you can see, when we go to the U-pull, it's going to be 2 calculations for the U-pull, and done, and we pick the largest out of these 8 calculations that we will be doing. Any question, guys? What color did we use with the U-pull? Green. Color Mother Nature. I didn't say that. Can I move on?
Yes, sir.
34 minutes. Ben, say something. Can I move on?
Yes.
Okay, good. Am I going too fast, guys? Too slow? Right speed?
Do you have an extra one of those? Or?
These? Yeah, I can make copies of these. Not a big deal. You guys want a copy? I'll make a copy. Not a biggie. I usually charge, but because you're my friends, I'll give it to you for free. Because you like chickens too. We are, remind yourself that we are still calculating for what? X. We haven't moved to Y yet. Wishful thinking, huh? Okay, I'm gonna be using U-pull. The U-pull. Let me just remind you guys quick. Let's go just back, Chad, back again. Okay, where are the U-pulls that can give you X? Okay, look at the, how about coming from the right, leaving to the right? That's give me an X, right? Right, going back to the right. How about coming from the left, going back to the left? That will give me an X. How about coming top and going back to the top? Would that give me an X? The U-pull always give you the dimension to opposite to where the conduits enter. But by the way, can I have a U-pull that the conduit enter from the right and leave from the left? Not a U-pull. A U-pull means they enter and leave from the same wall. Okay? So I have right to right, left to left, and right to right. Right? Do I have any other conduits? Everybody see what when we start here? Left to left, right to right. That's what I'm going to call them. Left to left, right to right. We always start with the left. And I'm going to tell you why. And so we're going to start left to left, left to left. Okay, if you guys look at left to left, there is 3.5-inch conduit engaged in a U-pole, bringing the conductors from the left, routing them through one conduit, routing them through the pull box, back again into another conduit that leads from the same wall, which is the left to left. The code says 6 times the largest conduit engaged in the U-pole, which is 3.5, plus all the conduits that sharing the wall with that U-pole. All the conduits that sharing the wall, that will give me, did they say 3.5? 3.5, this sound looks like 2.5, so 6 times 3.5 plus, let's go to the top, 3.5 plus 2.5 plus 2 plus 3. Did I forget anything, guys? So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Yes, sir.
Why do you count the 3.5 2 times?
Because you calculate for one conduit, the largest of the two engaged in the U-pole, then the second one still counted as sharing the wall with the U-pole business. You know, still sharing the wall with it. Good point, though. Why can't we count the two conduits that making the U-pole as one? We don't. One of them counts because it's the largest, the other one added up because it's still sharing the wall. Very good point. What's the sum? A gentleman or and a lady or 2 gentlemen? How much?
32.
32. Another gentleman or lady? 32. Thank you. 32 inches. Okay, what do you guys expect to do now next? Right to, can I have a U-pole right to left? That's not a U-pole. It has to be, if it's a U-pole, it has to be right to right. Right to right. Right to right. Right to right, buddies, it will be 6 times. Let's look at the right wall. The right wall, it says 6 times the largest conduit engaged in the U-pole, which is 6 times 4, because that 4 is engaged, plus all the other conduits in the same wall. Another 4, plus another 3, plus another 2, and plus another 1. So 1, 2, 3, 4, 5 conduits in that wall. We're good to go. What's the answer? 34. Another gentleman or a lady? 34. Thank you. 34 inches. 34 inches. Any other U-poles that we need to count to find X? For X. Okay. Now let's find, now all this will give us a dimension of X. Right? Is there any other calculation? Let's just review what we did, guys. We did 2 calculations for a straight pole. We did 2 calculations for U-pole, and how many calculations for an angle pole? 4. So for a total of 8 calculations. For these 8 calculations, Mr. Erbab, you're going to pick the largest number that you came out of these 8 calculations. That will be the dimension for X. Now, if this is not a standard, Brooks, what do you do if that number is not a standard box? Huffman box, what do? You go to the next standard. Okay. Anybody, did you guys look at all the numbers? Let's go look at them.
It's a 34
I'm sorry.
inch box.
So it's let's see, 34, 32, 29, 19, no, 27, 29. Um, okay, let's start with this calculation. 16 and 16. That's very small, right? So I'm going to count. I'm going to use this one this time. Drop this because it's small, right? So there's the first two. Okay, 27, drop this. 27, drop this. These are too small yet, right? So here's 4. How about these? 5, 6. Okay, moving on to 7. And which one is the winner for this box? 34 inches. Now, if you can't find the 34 inches, what do? You go to next standard. 34 inches. So please highlight 34 inches with black and a star. So X would be, I'm going to write here, X equal 34 inches. Oh, here.
It's not a cubic inch box, you're talking.
No,
34
dimension. Inch, not cubic inch.
3-foot box.
3.5, what is it? Yep, almost 3-foot box.
Oh.
34-inch box. Are you have a problem with a 30-foot inch? I can make you a 5-foot
Yeah.
box.
So right
34
now we're
inch box.
standing at 34 one way depending on what
Yes.
the side's gonna be.
Yes, that's the largest you have. We did 8 calculation and we picked the largest size out of these 8 calculations. Any question, guys? Any question, my friends? Any question about the X? Do you have enough oomph? It's 41 minutes. Do we have enough oomph to go for another? This should go faster now, the Y, because we went through. The Y, guys, is identical. Now instead of looking right to left, we're looking top to bottom. Okay? Shall we kick it?
Yep.
And then I'll buy you a chicken after that.
We've got that on audio, so I'm holding you to it.
It's a promise. They're cheap, man.
A
All right.
chicken- Are you gonna give us a chick or a full-grown chicken?
We'll see what we're gonna do. Okay. We're gonna do Y. To find Y, let's just talk about Y. Analyze Y before we go calculate Y. Do you guys agree with me? First, I'm gonna do the straight pull. How many straight pulls going Y? 1 straight pull. You can think of it as 2 as top, bottom, bottom, top. That's really 1. Okay. We treat them as 2 because we look at the top, bottom, and the second one, bottom, top. But in reality, it's really 1, 1. Okay. How many U pull that can give me Y? To give me a Y, it has to be top to top, bottom to bottom. Can you guys see the green U pull? Top to top, bottom to bottom. So 2 calculation for the U pull. Angle pull. Can you guys see the angle pull? It has to be top to left and then top to right, 2 calculation, or bottom to left and then bottom to right, 2 calculation. 4 calculations for angle, 2 calculation for straight, and 1 calculation for and 2 calculations for U. For a total of how many calculations? 8. 8 calculations. Does anyone does not see what we're talking about here? Everybody see there's an 8 calculation just by looking at the Y. How to find Y? There's 8 calculations. Anybody doesn't see that? Ryan, my friend? You all?
So I have a question.
Clear?
So like, I mean, if you look at that box and you know that 4 was your highest, and then you look at the Y-axis and you see the 5, can you just calculate the 5?
Yes, absolutely. The reason why I'm doing this, just to detail it,
Okay.
go step by step. Any question, guys, before we roll in? I want to remind you that straight is blue, and angle is red and green, and U is green. Okay, let's go ahead and roll into the calculation. Ben, my friend, are you? So I want to find Y. Find Y. Okay, the first one is, what is it? Blue. I will use blue for a straight pull, right? Straight pull. For a straight pull, let's go straight pull, guys. I'm going to go top to bottom. I'm going to go top to bottom. Everybody knows why. What's top to bottom? 8 times the largest conduit from the top going to the bottom is what? 3.5. What's 8 times 3.5?
8.
How much? 28. Two gentlemen agree on 28 inches. Good, great. Let's do the second one. The second one, what do you guys expect the second one to be? Bottom to top. Bottom to top. Same way. 8 times 3.5. 0.5 equal 28 inches. Okay, done with the straight poles. Done with the straight poles. Any question about the straight poles? Straightforward? No gimmicks, nothing? Don't have to sweat it. Let's grab the red. Did we do the red on the other ones? Red on the
Angle.
angle pole? Yeah, we'll do the angle pole. Any question, guys? I ran out of coffee.
Uh-oh.
Any questions? Any questions? No good? Move on?
Yes, sir.
All right. Guys there? All right, let's go. Now we're going to do angle. I want to remind all of us that we're still doing what? We're still trying to find one. So that's why I keep Y. Angle, pull. Angle, pull. Okay, angle. I'm going to go top to left first. Let's do top to left. Top to left. Top to left. Okay, top to left. You look at the top. The largest conduit engaged in an angle pole and going from top to left. The largest conduit is, so we need 6 tons. The largest conduit is 2.5 plus all the conduits in the same, at the same wall is 1.5 plus 1.5 plus 3.5 plus 3. This plus looks like a 4. Okay, did we get all of them? 1, 2, 3, 4, 5. Give me 1 second here. 3, 3.5, 1.5, 1.5, 6 times 1.5. Yes, sir.
Oh, when you see the top.
Coming from the top, going to the left.
5, why isn't it the 3, 5? It's only the one that's between the left.
The one that's engaged in the U-pole.
Okay.
Is the 3.5 engaged in the U-pole?
No.
No, it's not engaged.
That could
Sitting
be-
there
that could
doing
be
nothing.
like a
Well,
3
doing
inch and a
something.
2.5
but
inch or something.
Yeah.
You'd use the larger.
The larger conduit engaged in the U-pole.
Okay.
Yes, sir.
Why would we just look at the angle poles from the previous side and find the largest one that was engaged top and bottom?
From the previous side.
From X.
But we're finding it for Y now. We're looking at different wall. When you
just find the one that uses the same, uses the Y wall. So
if you're sizing X, it's really the same pole. But if you're sizing X, you're applying the rule on the in this case on the left wall. If you're sizing Y, you see the same pole you're using, but you're applying the rule on the top. What does that mean? What's the difference? The difference is the conduits that you need to add at the top are different than the conduits that you need to add on the left or the right side. No? Does it make sense? You're right, you can, if they're all the same, you end up the same answer. But if they're not the same, you end up with different answer. If the conduits on the walls are the same answer. Conduits on all the walls are different, you end up with different answer. Okay, what's the answer here, guys? Come on, 2 gentlemen or a gentleman lady. How much? 24.5 inches. Any other gentleman or lady? Agree, disagree? Okay, top to left. So we did top to left. What do you guys expect to do then? Top to right. Let's do the top to right. So now I have 6 tons, the largest conduit engaged in the process, which is 3, plus all the conduits going to the, plus all the other conduits, 3.5, plus 1.5, plus 1.5, plus 2.5. Okay? What's the answer for this? How much? 29. Another gentleman or lady? 29. 29 stands. 27. Another gentleman, lady. Come on, guys.
27.
27. 2 gentlemen agrees on 27. Who gave me 29? Who gave me the number 29?
You know, the window.
The chicken did.
Minus 2 points. Just kidding. I'm kidding here. 27, right? 27. All right. Anything, guys, top to left? Anything coming from the top going left or right? That's it. Now let's go back again. We're gonna go to the bottom. We're gonna go bottom to left, bottom to top, bottom to left, and bottom to right. Any question, guys? So we have 2 calculations, 2 more to go. Almost there. Hang in there. Hold your horses, Mr. Rabab. Angle pull. Can I move on? No. Slow down, Chad.
Yes, sir.
Too fast.
Good.
Good. If DJ says it's good, it must be excellent, man. Okay. Yes.
When you say top to right, isn't that if you go back to the main road?
A box, yeah. There you go, Mr. Rabab. Move and move and move and move and move. There you go.
Isn't that
Top to left. Coming from the top, exiting to the left. Top, top to right. Yeah, when you look at this, it's clear, right?
Yeah.
And color coded, man. Now, if you're color blind, we have a problem here.
No, I know.
Not you, Mr. Rabab. I mean, okay. So I'm gonna go, guys, just to keep reminding us. We're still trying to find x, a y, and we're still doing angle. So this is a y, and we're still doing angle. So I'm going to continue to do red. Angle, pull. We're still doing angle, pull. Okay, this time I did the top to right, left. I'm going to do what? The bottom. I'm going to do bottom, bottom, right, bottom to right. Coming from the bottom, going, no, let's do left, because just to be consistent, guys. So I need bottom to left, just to be consistent. Okay, coming from the bottom, leaving to the left. It's coming to the bottom, leaving to the left. That would be a 6 times the largest conduit engaged is 3, plus all the conduit coming from the bottom is 5, plus another 5, plus 3.5, plus 1. Who's the answer? Who's going to give me the answer? 32.5. 32.5 inches. I need another gentleman or lady to approve it. 32.5. Thank you. All right. What do you guys expect the second one to be? Very easy, huh? Now we went bottom to left. Where we're going to go then? Bottom to right. Bottom to right. So I'm coming from the bottom, going to the right. 6 times the largest conduit engaged in this angle pole, which is 1 in this case, plus all the other conduits in the same wall. 3.5 plus 5 plus another 5 plus 3. And what's the answer, Brad? 22.5. Another gentleman or lady? Okay, here's another gentleman. That's good. Any question, guys? How many calculations have we done for the U-pole? 4 calculations. Almost there. Hang in there. 2 more calculations for the U-pole, and then we're done. 4 calculations for the angle pole. 2 calculations for the straight. We're going to do the last 2 calculations for the U-pole, and then we are set to go for the dimension of the Y dimension, the height of that box. DJ, you're so quiet. You're good?
Yeah.
You're dangerous when you're quiet. Have to see, make sure that. Any question, guys? Yes, sir.
On the bottom to left,
Bottom to left.
you add up the rest of those 5.
Yep. You 6 times the largest conduit engaged in the bottom to left, which is 3, plus all the conduits sharing the bottom with that conduit. Sharing the bottom with that conduit. See how we're looking at the bottom? We're coming from the bottom. We're looking at the bottom.
Okay.
Make sense? We're the same thing, bottom to right. We're looking at the bottom, but we're choosing the one engaged in the U-pole going to the right. But we're still looking at the bottom. the angle pole. Did they say the U pole? The angle pole. Thank you, Brad. Extra credit for you. All right, let's go to the last two calculations. I just want to remind all of us that we're still calculating for y. Looks like a really good y, huh? And this time we're going to use Mr. Green, and we're using a U pole. Right, Brad? It's a U pole this time.
It is.
Okay, now we're straight here. Okay, U pole to find y. So I'm gonna go. It has to be top going back to the top. Otherwise, it's not U pole. Or bottom going back to the bottom. So since my conventions start top to top, top to top, coming from the top, leaving through the top. Coming from the top, leading through the top. Okay, so that would be a 6 times the largest conduit engaged in this process, 5.5 plus all the other conduits, 2.5 plus 1.5 plus 2.5 plus 1.5 plus 3.5 plus 3. So 1, 2, 3, 4, 5 calculation plus, let's put the 3 here and then erase that boy. And the answer would be 2 gentlemen or 1 gentleman lady, 22.5. Anybody disagree?
19.5.
Yeah. 19 or 22? 19.5. 19.5. Now who gave me 22.5?
They're out the window.
Out the window, okay. 19.5, right? All right, let's, now, Spencer, we went top to top. Now we're gonna go where? Bottom to bottom. Coming from bottom, going back to the bottom, right? So, bottom to bottom. Okay, let's look at the bottom, guys. Coming from the bottom, back to the bottom, okay? So 6 times the largest conduit coming from the bottom, leaving back through the bottom. That's why I say a U-pole. Otherwise, it would be a different pole. Times 5, plus all the other conduits. Don't forget the second 5, plus the 3, plus the 3.5, plus the 1. Okay, let's count them. 1, 2, 3, 4, 5. Perfect. 5 conduits. And who's my calculator? 42.5. 42.5. Okay, 42.5. Thank you. 42.5 inches. Looking at it, guys, which one is the largest now? Okay. So we did 8 calculations for y, 8 calculations for x. We chose the y, and now we need to choose the largest conduit for x, the largest dimension for x. From what you guys have looked at, 42.5 is the largest, right? So I'm going to go highlight that boy. I'm going to put 2, 3 stars next to it, and I'm going to say y equal 42.5 inches. Oops. And put it here. And what am I going to do, guys? Next to each other calculation, I'm going to cross it. So I'm going to go quick here, cross. So this is smaller. Just put a cross so I know that I checked it. I know I checked that one. I'll get back to here. And I know I checked that one, still small. And all the way to the angle pole, to the straight pole, small and small. Right? We checked all of them from the straight through the angle, all the way to the U. And my dimension is 42.5. 42.5 inches.
Is that 42.5 by 42.5?
42, that's the Y. What was the X?
Oh, that's 32 the X.
34. Okay, so 42.5. Let's go back to the whole box dimension. And all the way. Okay. Brad, if you don't mind, what was the X again, please?
34.
The X was 34 inches. And how about the Y? 42.5 inches. Here's the dimension of my box. My box is 34 by 42 and a half. If you can't find these dimensions, where do you go? To the next dimension. To the next dimension. Any question, guys? To the next highest dimension. Standard. Any questions, Brad? No? This is as ugly as it gets when it comes to So finding pull box calculation. Any question, guys? Since I'm recording, guys, I just wanna, can I just take one more little calculation, because all of the rest are gonna be the same. I'm gonna take one calculation, and then I'll let you go, just because I don't wanna stop the recording. I'm gonna find, remember how we said the rule, the special rule, we said the distance between every two conduits containing the same conductor. So I'm just gonna pick two distances, and the rest do it as a homework. I'm gonna pick, just for the heck of it, I'm gonna pick the distance between these two. I'm going to call it C1. Can you guys see that? And the distance between these two, I'm going to call it C2. Can you guys see that? I picked the distance between two conduits that contain the same conductor. That rule applies to any two conduits that contain the two conductors. You can do it for any two conduits that contain the same conductors. I need to find the distance between any two conduits that contain the same conductor. So as I drill my hole through the box, I have to maintain this conduit, this distance between the conduits. Otherwise, the insulation of my conductors will be damaged because of the angle or U-pull that I'm doing. Everybody's with me here? I'm going to calculate C1 and C2. Everybody, C1 and C2. Doesn't sound like C2 here, but it's C2. Okay, just let's do it. What's the code says? The distance between these two dimensions have to be 6 times the largest of these two. What's the 6 times 2.5? 6 times 2.5? 15. How about the distance between these two? 6 times 1.5? 9. That's it. So I'm gonna go back immediately to all the way, and then hold your horses here. Hold your horses, buddy.
I get it.
That's okay. And I'm gonna go distance between conduits containing same conductors or same cables. C1, Brad, can you read that one for me 6 times? C1 was 6 times? 2.5. Thank you. 2.5, that give me 15 inches. And the second one is C2 is 6 times 1.5, and that will give me 9 inches. Now you can go find all the C's for all of them. C3, C4, C5, all of them. The same. I'm just going to pick these two calculations, C1 and C2. C1 and C2. What does that mean, guys? Means the conduits, if I have my box here, as I drill the hole between these two conduits, which happen to be a 2.5 and a 2.5, I have to maintain a distance, that distance right here, which is C1, between them as you drill your holes. And the same thing for the conduit that were coming from the top. I have to maintain the distance here between them as I drill of C2.
So 9
The
inches
same
long.
the C2 is going to be 9 inches and 15 between for the C1. You can do it for any two conduits that contain the same conductors. Any two conduits that contain the same conductors. Any questions? If that was on the test, would you guys ace it?
If I can have this with me.
Yeah, yes, you can. You have the rules, all the rules. Not the example, but the rules. Up and down and left and absolutely. Gentlemen and ladies, that's all I have for this particular one. Thank you for listening.